All right, so we've determined that it was in fact a dependent sample, and we wrote that up. I wrote it right there. Namely, I mean, you can kind of tell it's not independent, but what would make it independent is you'd have to ask two separate groups, and one group would be asked about heaven, and one group would be asked about hell, and it wouldn't be making a grand total group of 1, 1, 2, 0. This was one group of people being asked both questions: do you believe in heaven? Do you believe in hell? And vice versa. All right. And what we want to know is there's a significant difference between P1 and P2. And that would be the proportion that believe in heaven and the proportion that believe in hell, right? So that'll make our null and alternative hypotheses. Let me write those up. Oops, I went too far. There it is. Okay. All right, step 1. You need null and alternative hypotheses. Here they are. All right, so let's make this a little bit more obvious what it means for us. For us, it's the proportion that believe in heaven is that equal to the proportion that believe in, oh my goodness, hell. There we go. And then for the second one, it would be not equal to. Are the proportions different? Okay. And these will always be two-tailed tests, actually, just the way McNemar's tests work. All right. Oops. Get that out of there. All right. There we go. Step 2, we need an alpha. They didn't give us one, I don't think, so we'll just make it 0.05 like usual. Why not? And if you really want 0.01, knock yourself out. But I'm going to do 0.05. Step 3, we need that test statistic. All right. And the formula for it's right up here. There we go. And we'll have to remember F12 is the one in the top right corner. Okay. So that's the frequency. So, oops, come back. F12 for us is the frequency in that top right corner, which is, all right, and I want absolute value signs here because I'm going to have to take that difference. So it's 125, take away the bottom left corner, which is the no, because what we're really interested in here is the difference here. Minus 1. The ones that are yes, yes, the ones that are no, no are not interesting to us. And then 125 plus 2. All right, let's go use Excel to find that for us. And you know what? I'm going to copy and paste that table. There it is. Okay, so now I want the absolute value of this number minus this number. Close that. Oh, I got to remember it. Minus 1. Oops. And I'm going to have to put parentheses around this. So parentheses in the front. Oopsie. Minus 1. Close parentheses. Divided by SQRT, parentheses. And again, that number plus that other number. Close parentheses, enter. So we have the test statistic right here. Yay. Let me go back and type that in. It's equal to 10.82. I mean, that is huge. That is a very large test statistic. Which is not, there's a difference in the proportions here. All right, but we'll figure that out in a second. Because we need to do our 2 step 4s, we're going to do both methods here. Classical and p-value method. Here they are, right here. And I definitely won't have time to finish both of them in this video, but that's all right. We'll start with the first one. Okay, now the critical region, we really only need z alpha over 2. So let me go back here and type in what alpha was. Alpha was 0.05. So z critical value, let me put it that way, is equal to norm dot inverse. I want alpha divided by 2. The mean is 0, standard deviation is 1. Now, technically, this is going to find the negative one because I did 0.025. The solution to that would be to do 1 minus alpha over 2, and that would give you the positive one. Or you can just find the negative one and then take the opposite of that. That's fine, too. Boom, I redrew it. There we go. So 1.96 is the critical value. All right, I'll be back here to keep working on this method.